Okay, guys, so we're going to continue and talk about properties of exponents, but this time we're going to talk about negative exponents. And you might be thinking, what the heck is a negative exponent? Well, let's think about what exponents are to start, right? So we have 4 squared is something like 4 times 4, right? And when it's a number as the base, right, we can figure out what 4 squared is, and we can say it's 16, right? Because 4 times 4 gives us 16. So 4 squared is equal to 16. Well, you might be thinking, well, what then does 4 to the negative second power mean? That is a negative exponent. Well, it's something a little different, right? It's like saying instead of numbers multiplying by themselves and getting bigger, right, they're going to end up being kind of getting smaller. And we're going to talk about how to do that today and how to simplify when we do end up getting those numbers. So 4 to the negative 2 is kind of like saying you're dividing 1 by 4 times 4, or 4 to the second power. So 4 to the negative 2, right, brings that 4 squared on the bottom and says you're dividing by 4 squared, right? You're dividing your number and making it that many times smaller. So looking at this one, we could say if 4 times 4 is the exponent, or 4 squared is the exponent that we're dividing by, then 4 to the negative second is equal to 1 over 16. So notice 4 squared equals 16, but 4 to the negative second is dividing by 16, right? We're taking a number and dividing it, making it that much smaller, okay? So a division by 16. So that's kind of a basic jump into what negative exponents are. But now we're going to look at kind of how we end up with negative exponents. So let's say we have a problem right here where we have 2 to the second and 2 to the fifth. We learned in the last lesson, right, that when we had exponents that we were dividing, that we had a rule that we could just subtract the exponents and get our answer. So we had 2 exponents, 2 2's on top, right, because 2 to the second power is 2 times 2, and then 2 to the fifth power on bottom, which was 2 times 2 times 2 times 2 times 2. And it canceled, right, 2 on the top and 2 on the bottom. So I'm left with 1, 2, 3 2's on the bottom. So this ends up being 1 over 2 to the third. Well, we just learned from what I just told you that when you're dividing by that exponent, 2 to the third, right, that is essentially saying that 2 minus 5 is equal to 2 to the negative third, or this bottom exponent of 2 to the third is the same thing as saying 2 to the negative third. Typically, we don't like to leave our numbers in with negative exponents, so we write them like this instead of like this, but you might see them in either form, okay? So let's think about what's happening in this one. We have a to the fourth, right? And a to the ninth. So we've got 9 a's on bottom, 4 a's on top, right? So 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. So yeah, okay. So when we cancel our a's out on top and bottom, we're going to be left with 5, but we're left with 5 on the bottom of the fraction, right? Which means that there's still a 1 on top, right? 1 over a to the fifth. Well, a to the fifth, right, because it's on the bottom, is the same thing, right, as a to the 4 minus 9, right, which is also a to the negative fifth. I wrote 2, I meant a to the negative fifth. Okay, so this and this are the same thing, just 2 ways of seeing it. Again, typically we want it to be in the positive form. We don't want to leave our exponents negative. So we're going to talk about that in a second. All right, so let's look at this one, which is already done for us, right? Where it's given us the 4 to the eighth. Well, we got to think about what would leave 8 exponents on the bottom. Well, let's imagine we had 10 on bottom. 1, 2, 3, 4, 5, 10 on bottom. Well, how did I get to 8? How many did I have to cancel in order to get to 8? Well, clearly I need 2 of these to cancel out so that I'm left with 8. And I'm writing A's and I mean to be writing 4's. Sorry, it's early. These should all be 4's, not A's, right? But you get what I mean here. The 4's should be canceling, right? 2 of them should be canceling to leave you 8 on bottom. So when we think about what this was 4 to the 2 minus 10, which gave you 4 to the 8. Okay, so what was on top? 4 to the 2 and 4 to the 10 on bottom. Because I had more on bottom, I'm left with my extras on bottom, and that means that that was a negative exponent. All right, let's look at one that had two parts to it. So this has x's and y's. So this is x, 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 right? All these x's. How many x's are left on bottom and how many y's are left on top? We're going to see what we're left with as y over x to the fourth. Well, how would we write that as a negative exponent? Well, this negative exponent, right, when it was a negative 4, it was next to the y. So it was, we had over here, we had x to the third y over x to the 7th, okay? If we're going to rewrite this with a negative exponent, we're going to say that it's not on the bottom anymore. It's just a negative exponent. So it would be y and then x to the negative fourth. And again, typically we would write the x to the negative fourth first because x comes before y. But in this case, I just sort of stuck it up here. If you wrote it the other way, it would probably even be better. X to the negative fourth y. These are the same thing. I just took the x to the negative fourth and put it first and put the y second. So let's look at these ones here and keep going. So 4 and 9, I could draw out all my a's, b's, or I could think about 4 minus 9, right? So 4 minus 9 is going to be my a term. Well, 4 minus 9 gives me a negative number, right? Gives me negative 5. And b, right, if I'm thinking about my b terms, I've got 5 minus 12. Well, 5 minus 12 also gets me a negative number, right? It gets me a negative 8. Sorry, a negative 7. So we've got our new exponents, right, would be a to the negative 5th and b to the negative 7th. But what if I don't want to write them as negative exponents? So here's working. What we're probably going to be ending up doing is leaving it as 1 divided by a to the 5th, b to the 7th. So just like I did here, right, when I had a negative exponent, I can think about that as being dividing by that term with a positive exponent, or dividing by 1 over 4 squared, right? 4 to the negative second is like dividing 1 by 4 squared. So the negative exponent will be written like this, but the positive exponent would be written on the bottom. Thinking about the next one. This one's kind of tricky because we're actually looking at things that have different bases. Well, this has a base of 5 and this has a base of 25. So we're going to have to rewrite this a little bit, okay? So 5 to the 0 power is going to be 1, right? Remember, anything to the 0 power is 1. Well, 25 to the 4th then is a division, just like this was 1 divided by 16, right? This is 1 divided by 24 to the negative to the 4th. So in order to see what the other exponent would be if it wasn't a division, right, we would be dividing by, we would be looking at a negative exponent here, right? So if this is 1 over, I should have written it over here, I'm sorry, 1 over 25 to the 4th, you would think this would actually be 25 to the negative 4th power. Okay, so I've taken that 4, I've moved it up to a whole number, right? There's still a 1 on the bottom. You can think about it that way. But this negative 4 is the same as this positive 4 when it's a dividing problem. Okay. All right, so let's do one more. Remember, we learned our distribution rule. Okay, so if I'm distributing this, I have x to the negative second over x to the negative 1 times 5 gives me negative 5. So now I'm going to think about what to do here. Okay, well, negative 2 minus negative 5, right? X, we have negative 2 minus negative 5. Well, negative 2 minus negative 5 is like negative 2 plus 5, which is going to give me x to the third. So what I actually end up with is x to the third, okay? And that is not a negative exponent, right? That's not a negative exponent. It would be something, right, over 1. So when we think about these ones, they started as negative exponents, right? But I can, once I subtracted, they became positive. And you don't have to have the 1 on the bottom, right? I was just showing you that as a fraction, right, we would write it like that, but this would not need to be there. So what does a negative exponent mean? Okay, so a negative exponent means that I have, just like if I have 4 to the second, right, that's equal to 4 times 4. If I have 4 to the negative second, that's equal to 1 divided by 4 times 4, or 1 over 4 to the second. So it's dividing by that term, that number, right, in the exponent denominator, right, in the denominator with that same exponent. Okay, are the positive expressions with negative exponents negative? So what this is asking you is, does this end up being a negative number, right? Does 4 to the negative 2 end up being negative 16? It does not, right? Because anything squared is not going to be negative. Okay, 2 positives are going to make a positive, 2 negatives are going to make a positive. Nothing about this means it's a negative number. What it is it's saying we're actually reducing the size instead of increasing the size exponentially by that many 4s, right? We're dividing by that many 4s instead of multiplying by that many 4s. So here, 4 to the second, right, is not a negative number. So no, right? It does not give a negative number. It gives a fraction, right? Or it gives a division. So what do you think this simplifies to be? Okay, so 1 over 2 to the negative third. What do you think is going to happen if the negative is actually on the bottom of the fraction? Well, again, this is saying that we are already a division. And so what's the opposite of this, right? Negative, think about negative as meaning the opposite, right? The opposite of that is going to be if I moved my term with my exponent back up to the top and I got 2 to the third. So if I'm dividing already by a negative exponent, then that's the same as multiplying by that actual exponent in a positive form. So you see that it's kind of like switching the place of the exponent. If it's a negative exponent on the top, we'll move it to the bottom and make it positive. If it's a negative exponent on the bottom, we'll move it to the top and make it positive. So we always want to write our exponents as positive. So let's say a to the negative n is equal to, if we're writing this as a rule, it's equal to 1 over a to the n. Similarly, let's write this one. 1 over a to the negative n is equal to a to the n. Because this one, we move it to top, it's kind of like it's over a 1, but we're not thinking about it that way, right? We're switching the place of it. But this would end up being positive. This would end up being also positive, but a dividing by a positive. So negative exponents are kind of confusing when you first start looking at them, but I think once you try some of the practice, you'll start to feel a little bit more confident about it. So give it a try. And this is the last big note section. So we'll do some review and take our quiz next.